So, today we're starting circular functions. And let's recall you were introduced to them, first of all, as the trigonometric ratios. From the right angle triangle, where we have 90 degrees, we have reference angle theta, and we name sides hypotenuse. How we name these sides? Opposite. Adjacent. And we learn about three functions, as a ratios, not functions yet. Sine.
Opposite over
Sine
hypotenuse.
theta, opposite over hypotenuse. Cosine theta, adjacent over hypotenuse. Tan theta,
Opposite over adjacent.
opposite over adjacent, which easy to memorize with the SOHCAHTOA. And for people who struggle with rearranging basic formulas, you can write them in the form like this, not at the same level. You write the middle letter above.
Oh, I've never seen that.
So you cover what you're looking for. For example, you're looking for hypotenuse, you cover hypotenuse, it's opposite over sine. You're looking for adjacent, it's hypotenuse times cosine. You're looking for tangent, opposite over adjacent. If you write it in this way, but for you guys, it shouldn't be necessary because you're all good with such easy rearrangement. Now, but today we will define circular functions. So if we look on the unit circle, why it's called unit circle? Radius 1. That's why it's called unit circle. Radius 1.
Well, that's a good circle.
So, if you take some point, so radius is 1. Radius of this circle is 1. We take some point on the circle. And we draw a radius to this. And this is angle theta. And we make such right angle triangle. Now, this point has coordinates x, y. And what x will be equal? And the hypotenuse is 1. X coordinate is the adjacent side. So adjacent equal hypotenuse times cosine. But hypotenuse equals what? 1. So you get x equals cos theta. In the same way,
Wait, what? Sorry.
in the same way, we can see that y equals sine theta. And so that's how now we can define sine and cos of any angle if we have any point on the circle, on the unit circle. So this will be angle. So now we can have sine and cos of the angles more than 90, whatever angle. What will be the sine and cosine of this angle? There will be, cosine will be x coordinate of this point, sine will be y coordinate. And tan
So it doesn't have to be right.
tan theta, opposite over adjacent, y over x, or sine theta over cosine theta. So we will be using for tan, now sine, as you can see, tangent is the sine over cosine. And, yes,
So for that point on the left, it's the same, x is cosine and y is sine.
yes, that is for any point
Any point
on
on
the unit circle, its x coordinate is a cosine of that angle,
So lost. I don't even
y coordinate is a sine, yes.
He needs a bit of clarification for the first bit, how you get x equals cos theta.
X equal, X is this. This is X, this is Y. X is adjacent side.
Yeah.
X is adjacent side.
Yeah.
Adjacent equal hypotenuse times cosine.
Okay.
What hypotenuse equal?
1.
1. 1 times cosine is cosine. So X coordinate is cosine. In the same way, Y is opposite. So we have that opposite equal hypotenuse times sine. 1 times sine is sine.
Oh.
And tangent is opposite over adjacent, so y over x or sine over cos. Now, x and y, now name numbers of the quadrants, reminding you that this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And this is the fourth quadrant. So we number quadrants anti-clockwise starting from here. This is Roman numerals. So, in the first quadrant, x is positive, y is positive. So sine positive, cos positive, and so tan will be positive. So all are positive in the first quadrant. Second quadrant. Here, what x is positive or negative?
Negative.
Negative. Y?
Positive.
So cos is negative, sine is positive, tan. We have positive over negative?
Negative.
Negative. So here only sine is positive. Here we will have only tan is positive because both sine and cos are negative. But negative over negative is positive.
And this one.
And here we have only cos.
Positive.
Only cos is positive. So to memorize that, you can use all stops to Caulfield.
All stops to Caulfield.
All stops to Caulfield. All positive, sine positive, tan positive, cos is positive.
All stops
To Caulfield. You can say all stops to city if you prefer to city, let it be to city. Or I can say all stops to Chelsea Heights. Now, let's introduce.
What's 2?
Let's introduce.
10. No, what does that mean?
It's 10. It means here
Opposite over adjacent.
tangent is opposite. Opposite is y. Adjacent is x.
Yeah.
Y over x.
Which is sine theta.
And y is sine theta, x is cos theta. So 10 is sine over cos.
Both of them are
Oh, this
negative.
is my dad tried to teach me this during the holidays and I did not
Both of them
understand it
negative?
at all.
Guys,
For negative.
all positive. In this
negative
quadrant, all three
X
positive.
and negative y, right?
In this quadrant, only sine is
that's
positive.
negative
Y
one,
positive,
negative
x
one.
negative, so y on x is negative.
Yeah.
Here,
So that's why tan is positive. Okay.
sine and cos negative because x and y negative, but negative over negative is positive, so tan positive. Here, x coordinates are positive, so cos is positive, sine negative, and negative over positive will be negative, so only cos positive. All positive, sine positive, tan positive, cos positive. To memorize all stops to whatever you prefer. Probably for most will be Caulfield.
first time we played.
Now,
Mansfield. I feel mini.
let's introduce another measurement, unit of measurement for angles.
Radiant.
We use degrees. Now we will add radians. What is radian? So,
Look them up.
let's recall the formula for length of arc. What will be equal this length of arc if this angle is theta? We have length of arc equal theta over 360
Length.
times 2 pi r,
Yeah.
or simplify
Yeah.
theta over 180 times pi r.
Yes, we have.
But like we touched it. No.
This is the length of arc.
Length of the radius.
Length of arc. Of the arc of this. This is L. Now,
What's R? R is radian.
R is radius of the circle.
Yeah, but
And L is the length
Yes.
of arc. Of arc.
L equals theta
Length of
over
arc.
360.
And then the formula for length of arc.
Wait, that makes so much sense.
Theta over 180
That's just
pi
a
r.
percentage of the whole. Yes.
As a fraction of the whole circle. Now, definition of the radian. One radian is the angle for which length of arc equal radius. The one radian is the angle. If this is 1 radian,
Yeah.
L equals R.
Where 1 radian is the angle of what?
Radian is the angle.
What is a radian?
1 radian.
One radian.
One
a
radian is a
the
such
at
angle
which
for
the length
which
of the arc will be the
length
same
of
as the
arc
length of the radius.
equal radius. So we have length of arc equal radius. What does it mean? What then theta over 180 times pi equal for 1? It has to be equal 1. To be length of arc equal radius, then theta over 180 times pi must be 1. So we will have L equals R. Yes.
I'm confused what you mean by 1 radian.
And it's a unit of measurement of angles. N is measured not only in degrees, there is another unit of measurement.
Radians.
Radians.
Okay.
And radian, 1 radian is a such angle, it's an angle, such angle, for which length of arc subtended by this angle equal radius. So this L, if this L equals R, then this angle will be 1
They're
radian.
related.
Thank God.
Okay.
The definition of the radian. Now let's find relation between the degrees and radians. And we can see it from here. For length to be equal R, what should be this equal? L equals R. That means theta over 180 times pi equals what? 1. For L equals R, what is in front of R must be equal what? 1. To have L equals R. If this is not 1, then L does not equal R.
Theta equals 180.
So here we got how we can convert between the
23.
radians and degrees. If we have that theta over 180 times pi equals 1,
No, it's circumference.
so to convert from degrees to radians, convert from degrees to radian, we divide by 180 times pi. So times pi over 180.
That's simplified.
To convert from radians into the degrees, we do opposite with times 180 divide by pi. So if angle, let's say 180 degrees, what it will be in pi? What will be in radians?
Pi.
Pi. 180 degrees equal pi
That's so funny, Mom.
radians. 90 degrees. What will be 90 degrees in radians? Pi over 2. Will be pi over 2. Pi over 2. What will be 45 degrees in radians? What? Pi over 4. How we convert from degrees to radians? we times pi and divide by
So what
180.
if you want to go from radians to degrees? Then we have to times by 180 and divide by
So
5.
let's
Pi
say
will be on the bottom.
convert 3 pi on 4 into the degrees. Convert 3 pi on 4 into the
3 times
degrees.
180.
540. What?
Yeah, 540
Over.
over 0.
Come on, you should be able to calculate it in your head easily.
540 degrees.
Convert 3 pi on 4 from radian
What's
to
540
degree.
divided by 4?
135.
Yes, I got it.
I was getting.
Daniel, how did you not get that?
B times by 180 and divide by pi. Pi pi cancels out. Pi cancels out.
And then it's
And
540 divided by 4.
We will have 3/4 times 180, which is 135. You divide 180 by 4 and times by 3.
Yeah.
Oh, what if you times 180
Yes,
by
it's the
3
same
and then
thing.
divide by 4?
It's harder.
Doesn't matter, but it's harder. Always easier deal with the smaller numbers always. Okay, makes sense how we convert between degrees and radians.
Yeah.
What's 180 divided by 4? 45.
Now,
Yeah.
What's 45 times 3?
so
135.
what is pi on 3 in degrees? 60 degrees, yes.
Degrees.
Pi on 3 will be 60 degrees. Now, another important thing is knowing exact values. Knowing exact values for certain angles, for sine, cos, and tan. But to memorize it, you need to memorize effectively only for sine. You don't need to memorize full. If you memorize for sine, you memorize for all. You will see it in a minute. How we can derive it? Let's consider equilateral triangle. Let's consider equilateral triangle with a with the side 2. With the side 2. As an equilateral triangle, what is each angle in this
60.
60 degrees.
You should.
And let's draw the height. So it's 90 degrees, so this angle will be 30 degrees.
Definitely not the first.
That makes sense.
And what will be this side? What this side
One.
is?
One.
What will be this side using Pythagoras?
1.
3.
Pythagoras,
Oh, you mean the middle line?
root 3. It will be root 3. Because we'll get h squared plus 1 squared equals 2 squared. Height equal root 3.
What?
Height squared plus 1 squared equal 2 squared. So you get height squared equal 3. So height equal root 3.
But it's not plus minus because
It's not minus because it's length. Yes.
Negative light.
Guys,
Daniel's sign.
so
That's tough. Dan.
as this is 30 degrees, this is opposite side. So what is sine 30 equal? Opposite 1 over hypotenuse. 1/2. What will be cos 30 degrees equal?
1 over 2.
Cos is adjacent, root 3 over hypotenuse. Root 3 on 2.
I'd be taking.
Cos or adjacent, we're looking into this triangle. Adjacent to 30 degrees is root 3.
You're gonna regret it, guys.
Hypotenuse is 2. Root 3 on 2. Now, what will be sine 60 degrees equal? This is 60 degrees.
Root 3 on 2.
Root 3 on 2.
We have to designate.
What will be cos 60 degrees equal?
1/2.
1/2.
I've got to bring a fork for my lunch.
You don't need to remember how it's derived, but I'm just showing where it's coming from. And then I'll show you how to memorize it all easily. Not just easy, just super easy. Now, to find for 45 degrees, let's consider the isosceles right angle triangle. Isosceles right angle triangle with the side 1.
Or no?
As an isosceles, what are those angles?
Oh.
They're the same.
What they equal? 45 degrees.
45 and 90.
45 degrees. Now, what will the hypotenuse equal?
Why are you clapping like that?
Root 2.
Ah.
Using Pythagoras, hypotenuse is equal root 2. So what will be sine 45 degrees equal?
1 over root 2.
1 over root 2. Or if we rationalize denominator, root 2 on 2.
These forever.
You don't have to remember, you don't have.
Shut up.
Question? Yes.
I don't get it. I don't think I ever learned how to rationalize thirds.
Rationalize. You just multiply both by root 2.
Okay.
Right.
Now,
Oh,
Shut up.
in the current curriculum, you don't have to rationalize denominator. Before it was compulsory, you cannot give your answer with a third in the denominator. Now you can. But to memorize, it will be easier to use root 2 on 2. So what will be cos 45
Root
degrees?
2 on 2.
Root 2 on 2. Now, let's combine it all into one table. And then you will see how easy you will memorize it.
Oh, I remember this.
This is an array.
Yeah, we did do this.
So,
we did this in your right.
we have 0 sine,
Grey minds think alike.
cos, and tan. 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, or pi on 6, pi on 4, pi on 3, pi on 2 in radians. What is 30 degrees in radians?
Pi over 6.
It's pi over 6.
Now quick.
30 degrees in radians, it's pi over
Get
6.
your money up, not your funny up.
I actually decided not to do it last night.
Now, let's look on the.
So I'm proud of that.
Let's look on the point corresponding to 0 degrees. Sine is y coordinate. What is the y coordinate of this point?
0.
0. So sine 0 equals 0. Sine 30 degrees we found is 1/2.
I didn't have 0 in my table. That's okay, I put it next to 90.
40 sine 45 sine pi on 4 root 2 on 2. 60 degrees root 3 on 2. Now 90 degrees of pi on 2 is this point.
1.
What is the y coordinate of this point? 1.
What?
No. Cosine will be going other way. Cosine 0 is 1, root 3 on 2, root 2 on 2, 1/2, 0. Yes.
Mr. B, I think I lost myself somewhere along here. What?
This is, I'm combining in one table values, exact values for certain degrees, for certain values of angle. 0, 30 degrees or pi on 6 in radians, 45 degrees or pi on 4 in radians, so we have
Jasmine Moore.
Or maybe the other way.
So for the columns, you've got different degrees.
Yeah.
For the rows, you've got
Right.
sine, cosine.
No, this is same angle.
That's what I'm saying.
Same angle, this is sine, cosine. And then we'll get tan. Now, can you see something about sine and cosine?
They're opposite.
They're opposite.
The same value. So you need to memorize only sign and remember the cos going other way. Now, two ways to memorize it. One way is, it's easy as 1, 2, 3. Look, 1,
Definitely
2,
learned that when you used to be
3.
already.
Always over 2 and square root. Is easy as 1, 2, 3. It's easy as 1, 2, 3. Second way to memorize, using your fingers. Using your fingers. So this is 0 degrees, 30 degrees, 45, 60, 90. So sine 30 degrees. We have 1, and it's always over 2. 45 degrees. We have 2 fingers here. Root 2 on 2. 60 degrees, we have 3 fingers, root 3 on 2.
Oh.
So either using your fingers or as easy as 1, 2, 3.
I think easy 1, 2, 3.
So
As easy as using your fingers.
it's up to you guys, whatever you feel more comfortable with.
Oh wait, 1, 2, 3.
Yeah.
Just gotta remember 90 degrees, 1, 0, 0.
Easy as 0, 1, 1.
And then tan is either sine over cosine or cosine over sine.
Now,
Sine over cosine.
hey,
Yeah. I got it down actually.
No, I didn't.
And then you do that.
Tangent is opposite.
that,
Yeah.
that,
And when you divide it.
now, let's find
Is it just sine over cosine?
sine and cos. Now, what is 10?
Sine over cosine.
Sine over cos. 0 over 1 is
0.
0. 1/2 over root 3 on 2.
1 over root 3.
1 over root 3.
1.
1/2 divide sine is 10 is sine over cos.
1.
1/2 divide root 3
One.
on 2. This is 1. This is
Root 3.
this
2.
undefined.
Inanimate. That's the
Inanimate.
word.
Undefined.
Same sense.
Now, what happens with the value of the sine and what happens with the value of sine and cos if we rotate 1 revolution? If we rotate 360 degrees, what will happen with the sine and cos? It will be same. We came to the same point.
It's a false.
We came to the same point.
Oh God.
We came to the same point.
Full circle.
So sine and cos are periodic functions. They repeat itself after what angle? 360 degrees. So
I think also because
Oh, right.
legs are away.
That's crazy, man.
if you listen, if question asks you find sine
Or both.
750 degrees,
It's 30.
we need to bring it. We need to
It's half.
bring
Oh,
it
that's half.
under 360
360 plus 180.
because it's repeat every 360 degrees. So we minus 360 times 2,
620.
720.
Oh,
Because when we, yes,
Oh.
sorry. So every 360 degree, when we rotate 360, we get to the same point. So we are here now. We measure angle. We rotating anti-clockwise. When we minus, we rotate opposite way. We rotate clockwise. 360, another 360. We get to the same point. So 750.
Do you remember the rotations that it had?
Yes. So we get that will be equal sine
Which is a
30
half.
degrees, which is
1, 2.
1/2. Which is
Oh
1/2.
my god.
It's like
in
it's
this
as easy
way-
as 1, 2, 3.
Now, What is,
Shesh?
makes sense how you got it there?
No, it's you're minusing it to get rid of the rotations.
Cos.
That'll make a difference.
Cos of
This is my celebration action.
1125 degrees. Find cosine of
360 times 1,000. That's 45.
What will be this equal to cos of what angle?
What's 345?
45 degrees. Why it's equal?
Because it's minus 1,000.
Minus 363 times, which is 1080.
We actually understand this.
So cos 45, which equal root 2 on 2.
Wait, but do you know for cos it's as easy as 3, 2, 1?
And
And for sine it's 1, 2, 3.
one more thing for today, very important. Symmetry
For tan,
properties.
it's 1 over 3. 3 over 2,
Symmetry properties.
and 3 over 1. That
So-
makes sense.
Symmetry properties of the circular function. Symmetry properties. If you, so, if we make angle theta here, angle theta here, what we can say about these two
They're
triangles?
mirrored.
Negative, we gotta go.
They are congruent.
Yes.
They are
They're
congruent.
similar triangles.
Now,
No, they're
what this end will be equal? Sorry, not this end. What will be this end? What this angle equal?
180
180 minus theta. Yes. So, does everyone understand that this angle is 180 minus? We go 180 and theta backwards. And Mika, what will be, what you can say about the y coordinate of this point and this point?
Don't tell her. No, let her do it.
What you can say about those triangles are congruent? Huh?
Both of the angles the same.
And both triangles are congruent. So what you can say about y coordinate? Y coordinate?
Why can't it be the same?
Y coordinate the same.
Yeah, and then we negative x.
And x is the, so we have that side 180 minus theta equals sine theta. Guys, this is the key to understand also why sine 180 minus theta equals sine theta. Sine 180 minus theta is a y coordinate of this point. Y coordinate of this point equal y coordinate of this point.
Yes.
So sine 180 minus theta equal exactly sine theta.
Theater's on the left.
What we can say about cosine of 180 minus theta? No. Negative cos theta. Negative cos theta. Why it's negative?
Because the x is negative.
Because x coordinate is negative. X coordinate is negative. Now, does that make sense?
Yes.
Now, let's do another triangle. Again, this is angle theta, and that angle will be 180.
270.
No, this angle is 180 plus theta. What is, if someone needs to leave to spot quietly,
Let's just wait. Let's just watch.
times 180, we almost finished. 180 plus theta equals negative sine theta,
Wait, Rap, wait.
cos 180 plus
That's not gonna leave it out
theta
there, bro. He won.
equal
Negative.
negative cos theta.
I get it.
And last one,
Same thing, but just different.
last one is, this will be negative theta. This will be,
Because his coach told him he shouldn't play footy at school because he'll just get injured.
this will be negative theta.
Yeah.
So what is sine negative theta equal? What sine negative theta equal? Negative sine theta. What is cos theta, negative theta?
The same thing.
Equal positive cos theta. Okay, that is all foundation to circular function. If you understand what we talked today, you will easily solve any problems with the circular functions. Like, subscribe, and donate to help fight terrorist countries, organizations, Iran, Russia, Hezbollah, Hamas, etc. Support Ukraine and Israel.